Hello, topic of this video is banking of road from SYJC lesson 1 rotational dynamics presented by Anita Zogrekar. Let us see what is banking of road and why it is necessary. First, we will see why it is necessary. For a vehicle moving on horizontal curve path, necessary centripetal force is provided by force of static friction between tire and road. But the frictional force is having upper limit, that is certain maximum value. Also, its value is not constant as it depends upon condition of road, tires and season. We know that during rainy season road becomes slippery, or due to oil spill on the road also road become slippery. So this coefficient of static friction is not constant. Thus, for safety of vehicle, we should not depend upon static friction. So, roads must be constructed in such a way that road itself provides necessary centripetal force. Thus, in real life, the surfaces of curved roads are tilted with the horizontal by some angle. This is called as banking of road, or in other words we can say outer edge of road is raised above the inner edge by some angle. This is called as banking of road. The angle made by bank road with horizontal surface is called as angle of banking. Now expression for most safe speed and angle of banking. Obviously when a road is banked, this is the diagram. The dotted line shows horizontal surface. Theta is angle between road and horizontal surface. Different variables that we are using. R is radius of curve path. Theta is angle of banking. V is speed of vehicle. Here we have completely ignored friction and other non-conservative forces like air resistance. Look at the diagram. Weight of vehicle mg acting vertically downward. N is normal reaction perpendicular to bank road and its components of normal reaction, n cos theta, which is exactly opposite to weight, and n sin theta. There are two forces acting on vehicle, weight mg that we have just seen acting vertically downwards, normal reaction n perpendicular to surface of road. We resolve normal reaction into its components. Vertical component n cos theta balances weight mg, and horizontal component n sin theta provides necessary centripetal force, or we can say balances centrifugal force. Mathematical expression: n cos theta equal to mg, n sin theta that provides centripetal force, that is mv square upon r. If we divide equation 2 by equation 1, we get n sin theta upon n cos theta. N gets cancelled. Sin theta upon cos theta tan theta equal to v square upon rg. M also gets cancelled. Therefore, v square is equal to rg tan theta, or v, that is most safe speed, is equal to root of rg tan theta. So it must be very clear to you that this most safe speed is independent of mass of a vehicle. Okay. So V is equal to root of Rg tan theta, that is most safe speed. Angle of banking, theta is equal to tan inverse of V square upon Rg. Angle of banking. These are two important formula. We need this while solving numerical. Now, speed limits. Let us see what exactly speed limits means. In practice, vehicle never travel exactly with most safe speed. For the speed other than this, the component of force of static friction. Now here friction comes in picture to help between road and the tire, helps to up to certain limit. Now since we are talking about speed limits, case 1, lower speed limit, that is when vehicle is moving with a speed less than most safe speed. So here in this case, horizontal component of n, that is n sin theta, is greater than the centrifugal force. So n sin theta is more than mv1 square upon r. In this case, force of static friction between road and tires is directed along the inclination of road in upward direction. Now diagram will explain it more clearly to you. Let us have a look at the diagram. Look here, everything is same. Dotted line represents horizontal surface, bank road, making angle theta with it. Vehicle, its weight acting vertically downward. N is normal reaction. Now Fs is the force of static friction. It is directed upward. Its component Fs cos theta, which is exactly opposite to n sin theta, and Fs sin theta is along n cos theta. So have look at the forces acting opposite to mg. We have n cos theta and n sin theta. N sin theta and F cos theta are exactly opposite, right? So mathematically we can write mg is equal to Fs sin theta plus n cos theta, and centripetal force mv1 square upon r is net effect of n sin theta and Fs cos theta. So mv1 square upon r is equal to n sin theta minus Fs cos theta. Why negative sign? Because these two forces are exactly opposite. Then rest of the process is same. Taking ratio, we get this lower speed limit v1 is equal to square root of rg tan theta minus mu s Mu s is coefficient of static friction upon 1 plus mu s tan theta. This is lower speed limit. Upper speed limit, that is when vehicle is moving with a speed more than most set speed, or horizontal component of n is less than the centrifugal force. N sin theta, that is horizontal component, is less than mv2 square upon r. In this case, the direction of force of static friction is directed along the inclination of road downwards. It is exactly opposite to what we have discussed in the previous case. Let us have a look at the diagram. Yes, mg acting vertically downward and perpendicular to bank road. Frictional force acting downward. Its components fs cos theta along with n sin theta and f sin theta along with mg. So here in this case n cos theta and f sin theta are opposite to each other. So mv2 square upon r is equal to n sin theta plus fs cos theta. Mg plus fs sin theta is equal to n cos theta, or we can write mg equal to n cos theta minus fs sin theta. As always, take ratio of or divide equation number 1 by equation number 2. We get V2, that is upper speed limit, is equal to root of Rg tan theta plus mu s upon 1 minus mu s tan theta. Okay. Now summary, what we have discussed till now. Most set speed, that is speed ignoring friction, V is equal to root Rg tan theta. Angle of banking, theta is equal to tan inverse of V square upon Rg. Speed limits, lower speed limit and upper speed limit. This is all about banking of road. Thank you, students. If you have any doubt, you can contact me anytime in physics lab. Thank you very much.